This is an experiment on half wave rectifier without filter. Circuit diagram for half wave rectifier without filter. This is 230 volts 50 hertz AC supply transformer, step down transformer. Here we will get 12 volts. So 1N4007 diode is connected, and this is 1 kilo ohm resistor, and the input waveform is sinusoidal waveform, and the output waveform during positive half cycle we get output, during negative half cycle there is no output, during positive half cycle we get output. So this we will check in the check experimentally. According to the circuit diagram, the secondary of the transformer, this is a transformer. Secondary of the transformer, it is connected to anode, and the cathode is connected to one end of resistor, other end of resistor to the secondary of the transformer. And across the transformer we will connect the CRO now. So this is CRO positive end, and this is CRO. Here I have connected CRO negative. We will check the input waveform. So this is the input sinusoidal input waveform. So from this we will measure the DC VM voltage. First you should adjust the knob to ground and adjust this line to on the x-axis. Now you keep this keep your CRO on the AC mode, so we will get sinusoidal signal. So you measure the voltage from x-axis to the peak. So it is 1.8 into the multiplication factor I have kept at 10. 1.8 into 10 is 18 volts. Here I am recording for 1 kilo ohm resistor. Vm is 1.8 into 10, that is 18 volts. Now with the help of multimeter we will measure the DC voltage across the resistor. Connect the multimeter across the resistor, positive end and negative end of multimeter across the resistor. So we are getting 5.78 DC voltage. Let us enter this into the tabular column, 5.78 volts. Now theoretically how to calculate the DC voltage? The theoretical value of DC is for half wave rectifier VDC is equal to Vm by pi. So Vm is 18 volts, 18 divided by pi. So how much I am getting? 18 divided by pi is 5.72 volts I am getting. This is theoretical value of VDC. So it is 5.72 volts. Now you connect CRO across the resistor. Keep your CRO in a DC mode. We will get the rectified output. This is my rectified output. So what is the value of output voltage we will measure? It is 1.8 into 10. So it is 1.8 into 10, 18 volts. From this Vm we will calculate the 𝑉𝑅𝑀𝑆. The 𝑉𝑅𝑀𝑆 is 𝑉𝑅𝑀𝑆 from the ripple is for the half wave rectifier it is Vm by 2. So 18 divided by 2 is 9 volts. So from this 𝑉𝑅𝑀𝑆 output we will calculate the amount 𝑉𝐴𝐶, because ripple factor is the ratio of 𝑉𝐴𝐶 by VDC. 𝑉𝐴𝐶 is equal to 𝑉𝑅𝑀𝑆 output minus VDC, 𝑉𝑅𝑀𝑆 square minus VDC square whole under root. 𝑉𝑅𝑀𝑆 is for half wave rectifier it is Vm by 2 minus VDC square. 𝑉𝑅𝑀𝑆 Vm is 18 volts I got just now from the output. 18 volts divided by 2 whole square minus the practical value of VDC. With calculator we measured with multimeter it is 5.78. Let us substitute that. 18 by 2 is 9 square minus 5.78 square. So 81 minus 5.7 square is 47.59. Square root of 47.59 is 6.89 volts. So this is 𝑉𝐴𝐶. Now we will substitute this 6.89 in RF calculation, 6.89 volts. So the value of ripple factor is I am getting 6.89 divided by 5.78 is 1.19. This is practical value of RF. Practical value of RF is 1.19, whereas the theoretical value of RF is 1.21. So both are approximately equal. Now we will calculate the efficiency. Efficiency is defined as the ratio of VDC by 𝑉𝑅𝑀𝑆 secondary. That from the input we calculate 𝑉𝑅𝑀𝑆 secondary, that value we have to substitute. So VDC by 𝑉𝑅𝑀𝑆 secondary square. VDC practical value is 5.78 divided by 𝑉𝑅𝑀𝑆 practical value is 12.72. So you substitute here and I'll get 20.64%. And PIV is equal to Vm. It is 18 volts. Vm for half wave rectifier, it is 18 volts for the half wave rectifier. In this way, so you follow this table on 1 kilo ohm resistor. First you from the input waveform you calculate the Vm value, and using multimeter calculate the practical value keeping in DC mode, and theoretical value you calculate with the help of the formula. Then ripple factor, it is the ratio of VAC by VDC. VDC already we got, VAC we will calculate. VAC is 𝑉𝑅𝑀𝑆 square minus VDC square. VDC practical value you have to substitute. 𝑉𝑅𝑀𝑆 is Vm by 2. So how we get Vm? This Vm is output waveform. From output waveform we are getting Vm divided by 2. After substituting this we will get VAC. Take the ratio of VAC by VDC, we will get the practical value of ripple factor. And efficiency, VDC by 𝑉𝑅𝑀𝑆 whole square. This 𝑉𝑅𝑀𝑆 is second input waveform. This 𝑉𝑅𝑀𝑆 is input waveform in the efficiency, and this 𝑉𝑅𝑀𝑆 is output waveform Vm value. So after substituting you will get efficiency, and PIV is Vm. Vm is the input waveform Vm. So in this way you can do experiment on half wave rectifier.